All right, how's it going, Professor? So today I'm going to be doing my exam number 2 demonstration as shown right up here. So for question 1, I'm supposed to correct one question on my exam that I did not receive full credit on. So I decided to do number 5, where I only got 0.7 out of 1, so I got 70% of it correct. Unfortunately, I was unable to evaluate the last property just to make sure the function was a subspace in func_R, all real numbers. So due to time constraints, I was only available to evaluate 2 of the 3 properties. But now checking it over with unlimited time, of course, I was able to see that although properties 1 and 2 were correct, property 2 checked out, and property 1 also checked out. Property 3, where a scalar would be in the subspace, that would not check out due to a scalar of -1. So I was able to check that out, and that would property 3 would not have checked out, would not have been fulfilled. So therefore, I got that wrong, unfortunately, but I figured out the solution. So if I had enough time during the exam, i.e. me, I would have gotten that right. So there we go for that one. So now on a question 2, show that H is a subspace of func_R by showing all 3 properties of a subspace are true. So going through the properties, property 1 is showing that the 0 vector in R3 is an element in H. So if A equals B equals 0, then the equation will be equal to 0. So if you put zeros in, you'll get zeros out. Therefore, the 0 vector exists, which means property 1 is satisfied. Now property 2. If A and B are in H, show that A plus B is in H. So if A equals B equals 0 and C equals D equals 1, and both of them are real numbers in H and they're real values, you can have f of x, which has A and B, and both those are equal to 0. So it spit out 0. Just make that look a little nicer. And g of x, and that's C and D, which are equal to 1. So g of x is equal to e of t plus sine t. And if we add f of x plus g of x, the result will still be in the function. Therefore, showing, we'll still be in func_R. Therefore, the result will show that property 2 is satisfied. Bada bing, bada boom. Now, number 3, property 3, scalar. This is one I missed on the exam. Let C be a scalar and let A and B be in H and exist in H. AET plus CB sine t, CAE e to the t plus CB sine t, remember C is the scalar, will be a real valued function that exists in func_R. This function, even though it has a scalar, will still be in the subspace. Therefore, property 3 is satisfied. Perfecto. Question 3. Find the dimension of the subspace, all that jazz. And given that x1, x2, and x3 are in the domain, is in the domain. So I broke up x1 like that. So x1 is like that with its coefficients. Same thing with x2 and its coefficients, x3 and its coefficients. And we just wanted to make sure the basis, check if these 3 columns were bases, was a basis. So I RREF it, and I notice that there's no free variables. Therefore, our vector is linearly independent. So all of the columns would be the basis. So there are 3 columns like that. So that means all 3 of these columns span H. So that means the dimension of H is 3 because 1 column, 2 column, and 3 column. So that equals dim H, which is 3. Perfect. Just like I've written right here. And number 4. So if A is a 2x2 elementary matrix performed by performing a row replacement on the identity matrix, show or explain why det A equals 1. So this is the identity matrix. If we were to swap a row, it would be like this. And the det of that is, awesome. The det of that is that. I think I got this one. 1, 0, and then we flip it. Awesome. Perfect. Yeah, I was mixing something up. Awesome. So yep, there we go. Shows det A equals 1. Let B equal B1, B2, B3, B4, and A is a 2 by 2 elementary matrix. So by this, we show A equals 1, 0, K1, and B equals B1, B2, B3, B4. And we calculate AB, which is this times that, which gives you this. We find the determinant of this, which equals B1, B4, minus B2, B3. And det A is equal to 1, the determinant of that. And then det B is equal to that. The determinant of this is equal to that. So then showing det A times det B equals det AB, it reduces to show that we do not get det A times det B equals det AB, mainly because of this scalar, this -1. So part C, we have to find the determinant of 0, 1, 1, 0, which is equal to 0, equal to -1. A is equal to 0, 1, 1, 0. All right, now part D. A equals 0, 1, 1, 0. B equals B1, B2, B3, B4. You find the determinant of A times determinant of B, which equals -1 times B1, B4 minus B2, B3. And that checks out, yeah. So det AB equals det A times det B, just focusing on the algebra. And then part E, if A is a 2 by 2 elementary matrix performed by scaling a single row of the identity matrix, show or explain why det A equals K. Where K is a scaling factor, write out A looks like. So if it's supposed to be scaled, A equals, I just did the top row. So 1, 0, and times K, which would be K0, 0, 1. Determinant of that would be K, because K1 minus 0, 0 equals K. And F, A equals K0, 0, 1, and then B equals B1, B2, B3, B4. Then AB equals this guy. Finding the determinant of this equals that, K B1, B4 minus K2, B2, B3. And determinant of A equals K. Determinant of B, this guy, equals B1, B4 minus B2, B3. And showing that determinant A times determinant B equals det AB is correct. Yes, I do get the same answer. Awesome, professor. Thank you. That is all. Take care.